Okay, in this video, which I hope to be a very short video, we're going to talk about factors and roots. Factors and roots. We know about factors. We've factored for a while now. Factors are the two terms, in this case 3x minus 1 and x plus 4. These are factors. But if I multiply them together, they'd give me a polynomial or a trinomial. Roots we've talked about before. Roots are where your graph or quadratic touches the x-axis. Now, I told you there's a connection between factoring and quadratics and finding the graphical answers. Today we'll talk about what that connection is. If I have factors, and I do, 3x minus 1 and x plus 4, I can find the roots, the zeros, the solutions, by simply using a zero property rule. The zero property rule says take your factors. Set each factor equal to 0. Just like that. And solve. What do you mean solve? I mean solve the equation by adding 1 to both sides, dividing by 3, and I get a solution, a location, an x-intercept of x is 1/3. Over here, this very baby equation, I get x to be -4. This means graphically, if I were to graph the quadratic in the beginning, that my graph would touch the x-axis at these two locations. So if I have factors and I want to know roots, I set each factor equal to 0. Let's go from the very beginning. Let's say I give you a quadratic to start off with. Let's say I give you x squared minus 5x plus 4. And I ask you to find the solutions, find the zeros, find the roots, whatever word you want to use. Find the roots using factoring. Well, that means we want to factor this thing. So let's factor this trinomial. Do I have a GCF to start off with between 1, 5, and 4? No, because 5 is prime. Jump straight into your chart. You want the factors of, in this case, a times c, so 1 times 4. So you want the factors of 4 that add to give you a -5. Remember, factors of a positive number can be between two positive numbers or two negative numbers. So 1 and 4, -1, -4, and I found it already. -1, -4 adds to be -5. That's the one I want. Take these two numbers and use it to replace my -5. -1x, -5x. Then group in GCF. We've done this a time or two. This should be a 4. There we go. So now GCF between x squared and x is going to be an x. So I get x minus 1. GCF here is going to be a -4. I am going a lot faster, so if you need a review on factoring, you might want to check out those videos. So there's 3 videos online. Other than that, I'm going to kind of go real quick through this. My parentheses are right. They match, so I get x minus 1, and I'm left with x minus 4. These are my factors. Got to know your vocabulary here. Factors are very different, very important. All right. If I multiply these two factors together, I'd get this trinomial to start off with. But your direction says to find the what? Find the roots. Find your zeros. Find your solutions. So if you have factors, you take each factor and set equal to 0. Solve. And what you get for answers, those are your locations where your graph would touch the x-axis. So if I would graph this polynomial on the calculator and go second trace and find my x-intercepts, my zeros, I'd find that would occur at x is 1 and x is 4. Okay. Now, while I'm in this video, we got to talk about going backwards. Sometimes they're going to give us roots, and they want us to find factors. They're going to give us roots, and they want us to find factors. What does that mean? Well, they're going to tell me that x equals 2 is a root, and they're going to tell me that x equals -3/2 is a root. but they're asking me for my factors. They're asking me for my binomials, like up here. They're asking me for x minus 1 and x minus 4. They're giving me my roots. They're asking me for my factors. We're kind of going backwards. Well, if I want to find factors, remember we took each factor and we set them equal to 0 here and here. So if I look at that, all I want to do here is make this right side 0. So I can make this right side 0 by subtracting 2. Well, x minus 2, I can't do that, but I can write down x minus 2 equals 2 minus 2 is 0. I got x minus 2 is 0. That means x minus 2 is a factor. Over here, this one's a little bit more complicated. Can you guess why? There's a fraction. Now we can't just add that fraction. We can't just add 3/2 to both sides. We've never seen a factor be written with a fraction in it. But we can get rid of fractions. We don't like fractions. I don't like fractions. Let's get rid of it. If I want rid of this fraction, right now I'm dividing by 2. Remember, the inverse or the opposite of dividing is to multiply by what you're dividing by. Multiply by 2. If I do that to one side, I can do it to the other side. And when I do that, you're going to notice your fraction goes away. 2 times x is 2x. Remember, if I divide by 2 and multiply by 2, that cancels because they're inverses. I'm left with minus 3. So I have 2x minus 3. So I'm a whole lot closer. If I add 3 to both sides now, I get 2x plus 3 equals what? 0. Remember, that's what I'm looking for. Once I get this equals 0, I remember that is a factor. So in this case, x minus 2 and 2x plus 3 are your two binomials that I can FOIL out to get my actual quadratic if I wanted to. So this sums up this video. Again, factors to roots or roots to factors. There is a connection between what we're doing with factoring and the quadratic graph. Very important connection.